In section 5.4, we were factoring and we were reducing an expression. Now we're going to simply take a look at the same idea. We're going to say to ourselves, well, what if we are multiplying or dividing fraction? Okay, so we're going to look at our steps here, but let me give you an example of what I mean. All right, let's take a look at this example. Very basic, this is numerical, no variables. But what we're going to do here is we're going to look at this and we're going to apply it to exactly what we're going to do with variables. So this example here is going to be identical to what we're going to do with variables, the steps. So the first step, okay, if the operation is division, we write it as multiplication by the reciprocal, which you should know by now. So we simply flip the right-hand side. So let's write this over. Okay? You've definitely seen this. Now, 28 over 54. 28 over 54. What can I reduce this to? Yeah. You said 10?
How did you? 20 over 4 over.
Right, how about answer?
27 over 14.
I'm sorry? 27 and 14. You're thinking too much. Just half the move. 27 and 14. So rewrite this now as 3 over 7 times 14 over 27. Okay? Now, what I want you to see next is a lot of people just multiply across, and then simplify. And you can do that, but it's really messy and it's much more difficult. Okay, so what I want to do is look at step 1. Somebody tell me how to do step 1. Factor all expressions completely. How can I actually do that here? How can I factor all my expressions?
27 divided by 3 is 9, and 14 divided by 7 is 2.
So we're going to factor. Answer the question, man. How do I factor them? You're telling me the right retort, but you're not answering the question.
You factor them by cross, like doing it across.
Okay, that's not factoring. Factor.
You take out a factor from each of the numbers that go across like, on the diagonal.
So tell me what 14 should be written as.
1 would be 2, and then 7 would be 1.
I understand, but you're not answering the question. Let's try this again.
Oh, 7 and then in parentheses 2.
Thank you.
Okay.
I didn't ask you to simplify. You see what you're doing?
Yeah.
Okay, please. A lot of you do this in your test. I took off points when people gave the height on number 2 at the back, or the second one. And I did that on purpose. It said find the base length. The base is 3, that's great, but people were writing the base is 3 and the length or the height is 10. It doesn't ask if the height should not be in your final answer. Is that clear? Answer the question being asked. This is universal. It happened a lot on yesterday's test. 27, how can I write that? 27. Yeah, what are the factors? 27.
3 and then 5.
Yeah. Okay? Or 9 parentheses 3, it doesn't really matter. But what I'm doing this is for a reason. Or the reason I'm doing this is to show you that when you cross cancel, see how originally Dan had said, well, let's just reduce this. You know, make this 2 over 1, which I agree with him. When it's simple numbers like this, I would do the same. But I want you to see now, watch. Once it's factored, you simply cancel your factors. That's all that's happening. And what are you left with? You're left with 2 ninths. The same exact answer you would get if you did what Dan said. He was like, all right, make this 1, make that a 2. Make that a 1, make that a 9. We just get 2 ninths. It's the same thing. But this method up here I'm showing you, although it may seem trivial and nonsensical for a problem like this, and I agree completely, is very useful when you have variables. You cannot just do it like this when you have variables. It will not work. So I'm trying to show you a demonstration with simple numbers of how this does work, and then we're going to extrapolate that idea and move into variables. Does that make sense? Ian? You good? Okay. So again, cross cancel or vertically cancel common factors, then multiply across. Well, when we cancel these, there's all these 1s left behind. So when I multiply across, I get 2 ninths. In step 4, I can't do anything. There's nothing to simplify. Okay? Let's look at an example now that actually is a little more difficult. So for this kind of example, this is what I mean. You can't just start cross-canceling without having factored. That's why I want you to factor in the last example. Take about a minute or so to factor each of those, please, on your own. Write it down, and we'll go over it. Again, work on factoring each of these. Look for common factors, please, amongst the numerators and denominators. Probably not today. I'm going to be in the lab working on a physics lab all day. What do you mean? Oh, yeah. I got you. Just wanted to discuss what about after school. Yeah, I don't know where I'll be. Drop by here. I might be, if I'm not in the room, I'll be in the lab most likely, which is probably 4 to 2 today. I will. If you don't see me in the teacher working with the grade. Yeah. So come with the science also. Nice. Factors, what do we got? We got some of these factors. Give me one of them. Nick, give me one of them. Pick which one.
On the bottom left,
Okay?
that's where it's one of the slide.
Good. Another one. Somebody else. Joe.
Pull the GCF to the top.
Okay, what do you got?
3x, parentheses, 1 minus x squared.
1 minus.
I wrote it.
Sorry. Rod?
Calculate x plus 5, x minus 4, all in parentheses.
Okay. Agreed?
Oh, we
That's awesome. Then you cancel 3x and
What do you notice? What happens here? With 3 x's, what happens then?
they go away.
They go away. What about the x plus 5?
They go away.
There's something else that goes away as well.
X for 1.
X minus 1.
Yeah, how does this work?
becomes a
That becomes negative 1 because they're opposite.
Yeah, I heard you. She had it first. Negative 1. Very good. Again, if I had 5 minus 3, I get 2. If I had 3 minus 5, I get negative 2, wouldn't I? So if I have any value and I switch the order of subtraction, you can always reduce this and just leave behind a negative 1. So let me put it over here. Sorry. All these are 1s left behind. And if I cancel these two, I leave behind a negative 1. Now remember, if you leave behind a negative 1 on top and the bottom, it does no justice, right? Because the negative 1s then cancel each other out. So you only leave behind a negative 1 in one spot, and the other spot gets just with 1. Okay? Right.
So, is the answer x minus 4?
It's up to you. I mean, I would write it like this when I have it. Okay? Or you can write it as, any of those are fine. Because you have negative 1 times x minus 4. It could be that. You can distribute the negative, or you can distribute the negative and then you can switch the order of them. Any of those are possible. Good SAT problem to look at, okay? Simplifying rational expressions. They'll give you an SAT problem like this, where the factoring is basic factoring, GCF, and just normal factoring. There is no AC method on the SAT. They will not give you a problem with AC method on the SAT. Okay, the only time they'll ever do something with a coefficient that's not 1, they sometimes put a 2 in front, because they assume people can factor with a 2x and just an x. But there's no what they call complicated factoring on the SAT. Dots is on the SAT a lot though. Dots is by far the most occurring one you're going to see for factoring. You're not going to see sum of cubes, you're not going to see difference of cubes. Is that clear? Dots and basic factoring and things like GCX. Again,
Why don't we basic factor?
I don't know. I wish I knew. I don't make an SAT. They assume that it's not needed, you know, beyond that, for the average person, you would say, which is probably true, to be honest. You're not going to study something in math and science, probably not going to use advanced factoring in their life. What is on the desk? Wait on. Are we always missing one, or am I missing one line?
We all do. It was always.
You do or
I
not?
don't think it really matters.
I know, but I like to be, 5 by 4 is nice.
We are.
But are we normally missing this?
Yeah.
So we always have this 3 right here? Huh.
brief draft.
Alright.
Division means we do what?
Yeah.
Keep change flip.
Alright.
Yeah, you have to do it because they insult you. But to multiply.
Okay? Do not divide, obviously. You don't divide. Division doesn't exist. Okay? It's multiplication by the reciprocal. And now you're just factoring. Chris, give me one of them. You pick which one. Bottom left or bottom right?
The bottom right.
Okay?
They have an x, so it would be x times x minus 6.
Good. Very good. Dan?
On the top, you have x minus 5, x minus 6.
Good. And what Dan noticed, or maybe he noticed it, is presumed did. See the common factor already?
Yeah.
Whenever you have one on the bottom, assume it probably show up on the top.
And then there's another.
Yep.
Yeah.
Right?
No, it's 2 times quotient x minus 5.
Quantities, quantities.
5.
Quantities. You mixed up the quotient of quantity. Sorry. Yes, and that's the other one that Dan was just mentioning. What's going to happen here? Yeah.
X minus 5 are going to cancel.
Keep going.
And x minus 6 is
Keep going.
Uh,
There's more.
oh, x, yes.
What are you left with on there? Yeah.
Wait, the x is more
Sure it
different.
does.
It's
Because watch. This is what I would have left. If I multiplied across, I would have 7x over 2x, wouldn't I?
Yeah, because it's multiplied together, they're not adding.
Again, we're multiplying, so everything is a factor. You can move stuff around. I can take this x over here. I can take this x and move it over here to this spot to show that it can cancel.
Wouldn't it be like 6x?
7x over 2x is what we have. Where do you see 6?
Because there's 1x there.
He's subtracting.
You're thinking about this. That would be x to the 6th. That's what you're thinking, okay? So your final answer is 7 over 2. Now, please notice something. Now, a lot of you are doing this in your test. By the way, good job with this overall.
You got
As a whole. What's that?
You got that?
Yeah, I mean, the average went from like, the first time was in the 60s, like 68. And the other class was like, or you were 70, they were 68, it was right around the same. The average was like an 88 or 89.
What?
That means
Yeah.
bagels.
Yeah, I know.
Now you go both of us.
It's a makeup test though, so I don't know how to think about it.
I need you to tell us. I pulled one out of
The
here.
first test was a 68 though, or 70.
Let's negate that.
I knew you were bagels anyway, I already knew.
Two.
I'm pretty sure you guys did it, I'm almost positive both classes did.
So how about after Christmas, you give us?
Yeah, I said after Christmas break, so it's
Oh,
surprise
sure.
there.
And then laser tag too.
Okay.
Go up both of those.
If we had a test, we.
Today would have been the
ideal day to bring changes.
Yeah.
Today would have been?
You can have a bagel for.
Sorry.
Green or tired?
I know, I wish I thought of it.
No, I
Alright, now, for this problem, notice that your answer is a numerical value. And we started with all variables. That's why this kind of a problem in the SAT tricks up a lot of students. Because the choices for this problem sometimes, some of the choices have variables in them, some are just numerical. 7 over 2 is just 3.5. So for these kinds of problems, a lot of people don't choose this answer. Because they're like, oh, there's got to be a variable, right? Look at all the variables in the actual original problem. See that? And it's a little misconception. People presume that, you know, we need a variable in the answer. All right, let's look at the last one. The last one is by far the longest one. Now, let's time. Time yourself from the time you start this. Okay? I'm serious. Because I'm curious how you'll do. Last class was way too long. And I told you they were just talking too much. Okay? I'll tell you when.
What's the
Well, you'll see when. Ready? I'm about to put it up. Right? At 40.
Should we raise our hand when we're done or something?
Just time yourself. It's not for me. Time yourself.
Ah.
Write down the time. We'll see how we do.
Well,
Oh yeah, have fun.
Christmas, where's your score?
I'm gonna hand out the problem sets.
it's the math spirit.
Copy much, Joe?
Oh, you know, you're distracting me, Mr. Melville. It's still hard.
Wait, now I flip this around.
complicated, so let's do this.
Yeah.
Over here,
Go to the answer.
AC, stop guys, listen, come on. AC is,
72.
B is, now, a lot of people have trouble with 72. The most common factors of 72 are
89.
8 and 9, you hear it all the time. Okay, 8, 9 is 17. So, I break up the middle term into 8x and 9x. If it helps you, you know what, for now I'll do this, please. If that helps you, do that. Because a lot of you are doing this, 8, 9, and then you're making those your factors. Those are not your factors. That's what you break the middle term into. So the middle term up here becomes 12x squared plus 8x plus 9x, that's these two now, and this 8x and 9x, this 8x and 9x takes the place of the 17x. Okay, again, these are not your factors. Now we use grouping. Using grouping, what do I take out of here? Anybody got a hand for me? Right. Dan.
Alright, so you take out a 4, then you can take out a 3.
No, out of here, Dan.
Yeah, you take out 4x.
4x, thank you.
And then you get 3.
Okay,
And then you get 3x plus 2.
good.
And 3x plus
Which must happen, right?
7. Yeah.
Again, people, remember, please, these factors have to be the same. Because what you're really doing now is you're taking out the GCF of 3x plus 2, and you're putting it right here. And then you're leaving what's left behind as 4x plus 3 and placing it over here. Okay, now, before you go on to the next one, let me make a suggestion. This 3x squared means that you have to have this. Does everybody agree with me so far? You can see that you have to. The only thing that gives you 3x squared is 3x times x. Okay? So, what might you think would happen here, Ryan? No. What might you think would happen here? Because you made a mistake with this, Ryan. You still haven't fixed that mistake.
I gave up a while ago.
Aren't you gonna get one that you have one years?
Yeah, there's a good chance that something that appears at the bottom is going to go into one of these, right? So don't you see this 3x plus 2 here? Give it a hypothetical and try putting a 2 here, just for the sake of it, before going into AC method. You put 21.
I put minus 21 plus 2.
Plus 2, yeah.
See?
That's not the answer, though. It's
But
not.
it's later 19.
Now, over here, this has to be minus 7 now. Why does this need to be minus 7? Because what's 2 times negative 7 going to give you?
No. Negative 42.
Negative 14.
42.
2. Negative 7.
I don't even know what the answer is.
Negative 14. Now, we're going to notice here that we have factors that do cancel. And if you actually multiply these out, take a look. Outer, what would the outer give me? How many x's would the outer give me? No. Chris? Negative 21x. Good. Outer. Outer means these two here. Inner would give me how many x's, Chris? So I have a negative 21x up here, and I have a 2x here. Ryan, that's what you were confusing. You were finding AC method with 21 and 2, which is right, but you were making your factors. And I said, you can't do that again. I specifically went into it here. The 21 and the 2 come up when you break up the middle term and you use grouping them, okay? So here, negative 21x and 2x yields negative 19x. Negative 7 and 2 makes negative 14. 3x times x gives you 3x squared. This is true. It does work. Okay? Again, this is just a technique that might help you to make it easier instead of going into AC method. All right, with that said, let's cancel. Cancel in.
The x4 in the top left cancels out with the x4 in the middle term in the bottom.
Good.
That cancels out with the one over there. It's so complicated. Alright, in the right term, I'll look in the right x plus 2 and x plus 2.
Okay.
And the x plus 2, x plus 2, x minus 7, and x minus 7.
So what you're left with is an answer.
X plus 5 over 4x plus 3.
Okay. factoring problems. This would be like doing 6 factoring problems. So you need to think about that speed-wise. I expect this to take you between 6 and 10 minutes. It took Dan, he was the first one done, 7 minutes exactly. After Dan was done, Julia was the next one, then Ian, and then Nick. And that was like a minute or 2 after that. So they were done around like 8 or 9 minutes. Okay? Others weren't even done yet. I expect this to be like at most a 10-minute kind of problem. It will take you a while, and I'll allot for that. I know that. Okay, but keep that in the back of your mind. Is that clear?
But then, well, this would be like a 21,
You both go at the same time. Show me your hand up. Okay?
this would be like a 15-point problem.
It'd probably be like a, like a 10 or 12 point problem at the end of it.
That'd be so annoying. If you're messing with one thing, then
Well, that's the thing. If you mess up one factor, you might not cancel. But that also helps you. It tells you, you know what? Maybe I gotta go back and see if I made a mistake along the way. Please write down your homework. We're gonna talk about the midterm for the next few minutes.
this one we really have to do, right?
Yeah, this is after break, honestly.
This is optional.
Oh. Since what was wrong with optional?
By the way, 5-4 is right after break also. Have that also. You should have done it last night.
Well, like, I did do it last night.
Where the Christmas gift?
That's right, I had to check another class in. I told them after break. So remember,
38 on this one.
after break, 5-4 from last night, which should be done, and 5-5 from this section. I'm going to stop the video recording and then go into the midterm. Okay, I'll talk about the midterm for a minute.